This video is for educational purposes. Please behave yourselves. Thank you.
So a couple weeks ago, I made a video about my Mayhem Cyberdeck. I went over the process, how I made it, which includes some of the specs, modeling, 3D printing, processing, etc. I wasn't happy with it. This video will be more of a comprehensive video of how I made my Cyberdeck, so perhaps you can follow along and make your own. Hello, I'm George Kostic. I'm a 3D artist, a composer, and a cybersecurity student. I'll be showing you how to make your own DIY Cyberdeck. Now, the specs here are subjective, but for your own curiosity, here are the components I'm using real quick. It's important to establish what functionality you want on your Cyberdeck, and I'm also a beginner in Cyberdeck making, so take this experience as what you could as a beginner as well. It makes more sense to start bigger and then go smaller from there. For example, I started with a heavy-duty case that I bought from Amazon, measured it real quick, and then I made a sci-fi platform design to fit the theme of cyberpunk or just general Cyberdeck looks. Then I 3D printed, and it took around 20 minutes, then just simply inserted it. No tape, no screwing or anything, just measurement with simple tolerance. So using case measurement, I found a small Bluetooth keyboard that fits inside the case and simply velcroed the back of the keyboard and the platform so it can easily be removed and or swapped for any reason. I tend to find velcroing things, it's a lot easier and more beginner friendly than screwing everything in, especially if you find high quality velcro. Things can stick in pretty well. In fact, I kept flipping my case upside down with, things inside of it and to test the stickiness of it. I briefly mentioned about making a platform and 3D printed. Well, that's kind of all I did in terms of modeling and 3D printing. All I did is I inserted a plane, extruded a little bit, and then I booleaned and then beveled it, and then that's it. There's a lot of cool designs and 3D models that you can find on the internet or just YouTube on how to show you how to make those kind of things, and they're pretty useful. The ESP32 device is running a firmware called ESP32 Dev. It's free and open source firmware that is similar to the Flipper Zero, and it was created by Cyberdeck. Anyhow, I took them out to figure out where the Raspberry Pi would go, or rather where it makes sense to place it. I initially was going to use a small breadboard for assembling the wires, but I thought that would be an overkill, so instead I used another ESP32 to the Cyberdeck and to the 16-character OLED and the 096 OLED, which is even more an overkill, but I thought it looked cool. And the purpose of the 16-character OLED is to display Mayhem in retro style, and the small OLED purpose is to ward drive Wi-Fi and find MAC addresses. Both of these devices were coded through the Arduino IDE. I didn't make the code, I just found the code free on the internet, and I just changed things around a little bit. I don't know how to code pretty much at all. The only thing I'm okay at is Linux scripting, which isn't coding, but you get the idea. But yeah, for some reason I really wanted to use a small breadboard in there, so I said whatever, and then I just added one. These little breadboards come with a sticky mounting that you can easily peel off and mount anywhere. The downside is it's permanent. Now let's address the main elephant. I probably should have mentioned this a lot sooner, but I bought this touch display, of course from Amazon, and I never really used it, and I finally found a purpose for it. This is one of the most bought Raspberry Pi displays I've seen around YouTube. That's probably why I bought one. Any display works. For some reason the touch doesn't work on the one I bought, so I gave up and just started using a mouse. Let's relax from all the nerdy stuff for a second and talk about a purpose, and that is, what purpose can Cyberdecks actually serve? Well, I briefly listed a list earlier, but why should you make one? And personally, since finishing 2 Cyberdecks so far, it taught me a lot about IoT components that I didn't know prior to making the Cyberdecks, and they're not expensive to make. You can extract a lot of the parts from old devices such as laptops, other IoT devices, and etc. I'm lazy, so I bought pretty much everything, and it cost me around $150. Making your own devices feels empowering since you get to control pretty much everything and not rely on manufacturer. You also get to decide how simplistic or the complexity of your Cyberdeck is. Otherwise, purpose vary. I mean, you could do it for pen testing, software-defined radio stuff, maybe you work at a data center, it could be a good thing for troubleshooting, and that looks cool, or just a device you can brag to your friends about. I know for a fact I'm not taking this Cyberdeck anywhere with me because of how sketchy it looks, but that's fine. It was a great learning experience, and maybe one day I can actually use it for something, but for now, it looks cool. Overall, I'm very happy with it. It has some minor problems that I'll probably never bother to fix, and I've mentioned this in my other Cyberdeck video, and that is, it's okay if your Cyberdeck has flaws. The device is for you. It's not a production product. No one's going to judge the minor flaws except maybe you. One last thing I want to add to the Cyberdeck is maybe some antennas and a mouse pad that is attached to the platform to complete the final look and functionality, but for now it's good as it is. The Cyberdeck is running Kali Linux, ARM. It's a pen testing operating system that is based on Debian. Of course, you can install any OS of any tools you want on the Cyberdeck, but I found that flashing Kali on Pi is the most appropriate for our use cases. And yeah, another thing I forgot to mention is that I'm running dual fans. One is intake and the other one is exhaust to keep the Raspberry Pi cool, which I don't think it's working that well since the Pi is a lot further down than necessary, but in all honesty, I haven't tested it. The battery pack lasts about 2 hours when fully charged. I don't have any reason to test this, so I'm not sure if that's accurate or not. Raspberry Pi is very, very, very picky with their power inputs, and almost no other battery pack will work. Thankfully, mine seemed to work and it was able to draw out enough voltage. But yeah, that's it for this video, and as always, I hope you learned something. Thank you for watching.